بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. Hello everybody, and welcome to our lecture today, lecture 4, electronic health records implementations and the big data. As you know, in the previous lecture, we provided an overview of the medical information systems and described the medical information systems areas of applications, such as clinical information system, nursing information system, radiology information systems, and order entry systems, and identified the different subspecialties of the medical information systems. However, our lecture today will be about the importance of electronic health records and health information systems, and the requirements for applying health electronic records in healthcare system of any country. Sorry. Moreover, we will define at the end of this lecture, the big data and resources of such health big data, such as the social health and sensor informatics. Finally, we will discuss the challenge rising with big data. So our learning objectives at the successful completion of this lecture, the student should be able to understand the significance of electronic health records and health information systems, and he'd be even be able to have an overview about the electronic health implementation requirements, and defining the big data and data analytics, and identify social health and sensor informatics, and discuss challenge rising with such big data. So as we mentioned in our previous lectures, electronic health records could be considered to be the center of health informatics. And as we mentioned also before, electronic health record is defined as, just as a reminder, an electronic record of health-related information of an individual that conforms to nationally recognized interoperability standards, and that can be created, managed, and consulted by authorized clinicians and staff across more than one healthcare organization. So the National Electronic Health Records has the potential to improve the quality, safety, efficiency of healthcare, and moving from scattered information system environment to fully integrated electronic health record systems across any administrative health care systems will increase the ability of clinicians to have timely appropriate and secured access to patient information, patient also can better manage their condition and communicate with their care providers anytime and anywhere. Therefore, and in order to apply a national interoperable health electronic records in any governmental healthcare system, they are an essential component proposed for being applied or implemented, such as consumer and care providers identifiers, standards for information exchange and protection, and finally underlying physical computing and networking infrastructure. Okay, so the importance of national electronic health record. So the question that we might ask ourselves about is, what's the significance of having a national electronic health record across the country? So, as all know, people over the age of 60 place higher demands on the healthcare system. The growing and aging population base continues to increase demand for healthcare services, especially because of chronic diseases. They require healthcare management over an extended period of time, and often across multiple care providers. So, according to that, a better coordination of service delivery across different parts of the health sector will provide timely, efficient, and effective healthcare for both patients and providers. So the government's initiative to build a nationwide electronic health record will support consumers, healthcare providers, and managers, and the population as a whole. So in more details, as we can see in this slide, electronic health records will ensure the right consumer health information is electronically made available to the right person at the right place and time. It also enables the health sector to more effectively operate as an interconnected system, overcoming the current fragmentation and duplication of service delivery. Electronic health records also enable multidisciplinary teams to electronically communicate and exchange information and provide better coordinated healthcare across the continuum of care, which in turn improve healthcare quality and patient safety. It also improves the quality, safety, and efficiency of clinical practices by giving care providers better access to consumer health information, clinical evidence, and clinical decision support tools. And finally, electronic health records provide consumers with electronic access to the information needed to better manage and control their personal health outcomes. So, however, the previous objectives that we mentioned in the last two slides will not be achieved without successful development and implementation of electronic health records. The many internal and external stakeholders and importance of the health industry where patient lives are at risk, and the regulated nature of the industry means implementation of a national electronic health records require careful planning at all levels. Accordingly, there is one key to successful implementation which is a strong leadership from a variety of rules such as health informaticians, physicians, nurses, and health information managers. It requires a multitude of personnel with different talents and skills, all working toward the same goal. Furthermore, there are 6 teams for electronic health records implementation best practice: the effective communication, successful system migration, technical equipment supporting and training, safeguards for patient privacy, a focus on improved efficiency, a sustainable business plan. Furthermore, it can be helpful to have a framework for considering the processes and stakeholders in the development and implementation of electronic health record. The system development life cycle ensures the implementation of different components will be managed with a well-developed project plan. The system development life cycle includes 4 primary phases: planning and analysis, design, implementation, and maintenance and evaluation. Appropriate architecture foundations in the form of consistent information standards, information security protocols, computing infrastructure, and proper networking are significant to effectively provide a platform for health information exchange across healthcare organizations of any country. So, the overall information technology, architecture requirements, and logistics. There are 5 major requirements to build a national electronic health record. Identification and authentication, information standards, information protection, computing infrastructure, and networking. We are going to describe each major requirements that we need to build a national electronic health record in details in the next slide. So firstly, and for the identification and authentication, design, build, and implement a national solution to enable the unique identification and authentication of healthcare system patients and care providers. The identification is the provision of functions to uniquely identify patients, care providers, and care providers organizations to ensure that information about the right person is going to be sent to the right care provider. Identification services should include the allocation and management of unique identifiers and the provision of directors that allow care providers to be located by the name and by the type of services they provide. Okay. The second theme is regarding the authentication, authentication is the provision of functions to securely address, authenticate, and transfer messages from one care provider to another to ensure that the information gets to the right providers in a secure manner. Second theme is information standards. So standardized health information is achieved through interoperability. It refers to electronic communication among organizations so that the data in one information technology system can be incorporated into another. So it focuses on development of standards for content and messaging and adequate security and privacy safeguards. So elements of semantic interoperability are language, terminology, and clinical coding, information structure, clinical protocol, and processes. So such standards facilitate use of common terminology, govern the way health information datasets are stored, secure messaging infrastructure, and transmission, and define the message acknowledgement standards. So in any future project, for example, that try to apply electronic health records at the nationwide, sorry, there's a standard that need to be used regarding the information standards. For example, of these standards is it need to have information system interoperability, technical and functional. It need to have data standards, vocabularies and terminologies, structure and coding systems, information content standards, like reference information models like health level 7, HL7, information exchange standards that use the same, health level 7, privacy and security standards by using virtual private network, functional standards, interoperability standards, standards development organizations, and finally the business standards by using clinical guidelines and health information management practices. Okay? Okay, so the third themes is now the third theme is information protection. Design and implement a consistent national legislative framework for information protection, privacy, and consent. The mechanisms are needed to ensure secured information transaction between different decentralized electronic medical records. A cross-organizational platform communication could be used to share sensitive information. But how? The first step is to build a national security domain. At the next phase, those national secure and interoperable domains can be linked together with the help of the internet portal like Common Zone. Okay? This figure is illustrate a secure cross-platform model with interoperability services. So we mentioned in the previous slide that the mechanisms are needed to ensure secure information transaction between different decentralized electronic medical records. Across-organizational platform communication could be used to share sensitive information. So how that could be happened? First step is to build a national security domain. At the next phase, those national secure and interoperable domains can be linked together with the help of an internet portal like Common Zone. As shown in the figure, the major benefit of this kind of model are that it requires minimal change to present legacy system. So as we can see in the figure, a platform integrates two or more security domains. Integrate enterprise-wide and regional platforms and form a national secure and interoperable platform. The model uses inter-domain zone, offering security to all domains. The main task of the platform is to offer a centrally managed security services for cross-organizational predefined communication. Okay? So, basic security services of the cross-platform domain are security policy bridging, cross-domain identification and authentication, certification services, static privilege management, and auditing services. And an example of information security tools is router, IP addressing, firewall, patches, antivirus, spam, spyware, and password passphrases. So also unprotected shares, web-based email file sharing, physical access and backups, public key infrastructure, and finally audit trail. So the fourth theme of applying and building electronic health records at the nation level is computing infrastructure. So by establishing mechanisms to encourage care providers to invest in the implementation and maintenance of an acceptable baseline of computing infrastructure such as desktop, laptop, handheld technology and tablets computers, servers and networks, wireless networks, voice recognition systems for transcription, physician orders and medical records, barcoding technology for drugs, medical devices, and inventory control, information security systems. And the final theme is for building electronic health records at the nation level is the networking. National broadband services is recommended to be used by all care providers as connectivity infrastructure. Broadband connectivity is one of the key foundations for sharing electronic information between care providers. Optical Ethernet could be used throughout this national network of cities. So in order to have a connection between facilities in different cities, each facility has to have an electronic medical record. The hospitals already have electronic medical records. However, the primary care providers and other community care providers will be provided with electronic medical records. Then in each city, hospital will be connected with those community care providers via LAN or WAN architectures. Consequently, facilities from one city will be connected with facilities in another city via national central hub infrastructure. So, an internet broadband access will be used as well as a virtual private network. It reduces networking costs significantly because of much of maintenance is performed by internet service providers or provider. A gateway is employed to link two different network types together, and this way each city network will be linked with other city networks. In addition, a file server is useful as a computer system running specific application in large organizations. It's also important to apply security devices such as routers and firewalls at every level in the networks. So this figure in this slide is illustrate the electronic health record networking. So as we can see, an internet broadband access can be used as well as a virtual private network, which in turn reduce networking costs significantly because much of the maintenance is performed by internet service providers. A gateway is employed to link two different network types together, and this way each city network will be linked with other city networks. Okay. Okay, so the big picture of what we mentioned already in the previous slide could be summarized in 5 main domains that we are going to discuss in more details in the coming slides. Okay. So the first domain is the facilities. In each city, application such as hospital electronic medical records, physician office electronic medical records, pharmacy system, and public health services will have their own data storage. Those applications work like point of service. Okay. Let's have an example. For example, an electronic pharmacy system will be implemented which support an electronic transfer of prescription between care provider and community and hospital pharmacies. Now, applications in different facilities are pushing data to repositories for publishing. Okay. Repositories. The received data will be stored in databases, repositories, for health records, drugs, diagnostic images, laboratory, each containing a significant subset of the overall electronic health records data available for sharing with other repositories. All exchange of information is done using standards-based interfaces. They are made up of messages using standard message definitions such as DICOM and Health Level 7. Those messages are further supported by data standards including reference technologies such as SNOOM CT and classification system. According to Vogel, it's recommended to use architecture type for data storage, mostly decentral federated architecture, central patient index, decentral metadata index, and patient summary data repository, decentral repository for full electronic health records data, because 33% of European countries are in favor to this type. The third part of the big pictures is the health information access layer. Sorry. So a middleware software is needed to make different applications communicate with each other and with system level services. Health information access layer HAIL is where information will be verified for correct patient identity and appropriately anonymous depending on the intended use, the location and provider identification added where appropriate, and the identity of requester checked for authorized use. Okay? So as you can see in the figure, the health information access layer is where information will be verified for correct patient identity and appropriately anonymized depending on the intended use, the location and provider identification added where appropriate, and the identity of the requester checked for authorized use. So the health information access layer act as a gatekeeper that provides security and privacy services. It's made up of communication services, messaging protocols to exchange information such as authentication and authorization, access control, encoding, decoding, and encrypt, decrypt. Okay? Okay. So registries use unique identifiers of key attributes, in particular the patient's provider, location, user, and clinical terminologies to ensure that the right clinician or user accesses and provides the right information on the right person in relation to the right location. Okay? Longitudinal record services. So it's significant for collecting and bringing together information from registries, repositories, and other sources. In addition, there needs to be a set of services that deals with accessing and managing that data, and those could be software application, such business rule services and normalization services. Moreover, the implementation of separate internet-based portals for consumers and care providers that will provide access to a set of nationally coordinated, validated, and appropriately focused health knowledge sources. Okay? So electronic health records will improve healthcare in any governmental health organization. So how electronic health records will enhance the healthcare system at the country level. So the consumer will be supported to stay healthy through access to reliable health information sources, tailored care plans, and automated care providers monitoring of personal health status. Uh, the care provider will deliver care more efficiently and be able to more easily share information and coordinate care delivery with other providers. In order to have an effective electronic health implementation, uh, interoperability could increase the usefulness of implementing appropriate information technology architectures. The foundation's work should focus on implementing the basic infrastructural building blocks required to enable the effective electronic sharing of information across the health sector. So these include the implementation of consumer and care provider identifiers, the establishment of standards, rules and protocols for information exchange and protection, and the implementation of underlying computing and networking infrastructure. In order to realize the sharing of medical information, coordination of medical, as well as the efficient and cost-effective health information system through the construction of distributed and high integrated platform, the medical and health information system infrastructure based on cloud computing is proposed. So, cloud computing is defined as the practice of using a network of remote servers hosted on the internet to store, manage, and process data rather than a local server or personal computer. Cloud-based application can easily scale up or down as demand change. From a development perspective, they are flexible and accessible. They can be updated centrally and rolled out from their test environment easily. Cloud-based application can potentially perform better on cloud platform dispersed around the country or the world, improving access. So that flexibility extends to include collaboration, creating increased opportunity. Big companies can partner with smaller innovators or third-party developers to execute on business and customer engagement strategies in a secure, agile, and cost-efficient environment. Uh, so, as you can see in this figure about Keystream clouds and using of cloud computer, so integrating individual information system into a cloud-based system saves time on administrative tasks. Syncing data between applications and updating records and files present in multiple apps. Sharing information between apps gives users data collected by other departments to apply to their tasks. Demographic or billing information collected by a department using a different application within the cloud-based health information management system can give users in other areas new insights. So the main advantage of cloud computing is its low cost. All kind of information technology measures such as hardware, software, human resources, and management are cheaper when implemented on a large scale. Cloud users such as smaller hospitals and medical practices can easily get a cost-effective and on-premise information technology solution through cloud computing without the need to purchase or evaluate hardware or software, or to hire internal information technology staff to maintain and service in-house infrastructure for mission-critical applications such as electronic health records. So, in other words, cloud-based health information management systems provide general cloud computing benefits. For example, high availability, reduce hardware maintenance, reduce operation expenses, and added benefits, particularly for larger organizations. On-site control and maintenance is not required, so institutions with multiple locations do not need resident information technology department to manage information apps. The result is that the user can focus on critical tasks without having to incur additional costs with regard to information technology staffing and training. Electronic health records are created and stored digitally, so implementing solutions designed to take advantage of digital file format potentially have tremendous value to healthcare organizations. Uh, Better management of health information and records leads to more accurate records, decreasing human error makes health information management systems for health information technology infrastructure. So, uh, other topics for this lecture is the big data. Big data, according to International Data Corporation worldwide, spending on information and communication technology will reach 5 trillion US dollar by 2020, and at least 80% of the growth will be uh, uh, driven by platform technologies, which encompass mobile technology, cloud services, social technologies, and big data analytics. Applying big data to health is not only important to biological and physical sciences, but equivalently important to what has traditionally been considered as soft sciences, such as behavior and social sciences. It is well known that human behavior is a significant driver for environmental problems such as climate change, air pollution, and medical issues. So the question now it is what the definition, what's the big data? The definition of big data. So by definition, big data in healthcare refers to electronic health data sets, so large and complex that they are difficult or impossible to manage with a traditional software and or hardware, nor can they be easily managed with traditional or common data management tools and methods. Big data in healthcare is overwhelming not only because of its volume, but also because of the diversity of data types and the speed at which it must be managed. So the totality of data related to patient healthcare and well-being make up big data in healthcare industry. It includes clinical data from clinical providers order entry, and clinical decision support system, physician written notes and prescriptions, medical imaging, laboratory, pharmacy, insurance, and other administrative data, patient data in electronic patient records, machine-generated sensor data such as from monitoring vital signs, social media posts, and web pages, and list patient-specific information including emergency care data, news feeds, and articles in medical journals. So, uh, so health informatics applications are known to generate datasets that are complicated to store, untangle, organize, process, and above all, interpret. By digitizing, combining, and effectively using big data, healthcare organizations ranging from single physicians' offices and multi-provider groups to large hospital networks and accountable care organizations stand to realize significant benefits. Potential benefits include detecting disease at earlier stage when they can be treated more easily and effectively, managing specific individual and population health, and detecting healthcare found more quickly and efficiently. Numerous questions can be addressed with big data analytics. Certain development or outcomes may be predicted and or estimated based on a vast amount of historical data such as length of stay. Okay, so sensor informatics. Advances in sensing hardware have been accelerating in recent years, and this trend shows no signs of slowing down. So, big sensing data in healthcare are all around us, enabled by technologies ranging from nano and microelectronic advances, material, wearable mobile computing, and telecommunication systems, as well as remote sensing and geographic information system have made it possible for sensing health information to be collected pervasively and unobtrusively. Uh, uh, so, so as illustrated in this figure, the inner loop presents technologies for sensor components, while the middle loop presents devices and systems potentially owned by each individual or household, such as wearable mobile computing or body sensors networks, while the outer loop presents sensing technologies required at the community and public health level, such as the remote and environment sensing, geographic information, and telecommunication. Mobile health. Nowadays, smartphones have become an inseparable companion for more than 1.75 billion users. The data generated by the user smartphone provides highly descriptive and continuous information anytime and anywhere. The penetration of smartphone, which has reached over 20% of the total population in some cities such as Hong Kong, makes it logical to use it as a personal login device of health information. Uh, the, the, the new generation of smartphones has a wide range of health apps with standardized protocol to connect to sensors provided by different companies. They can potentially serve as a platform to centralize health data from which additional new information that was previously untraceable by individual sensors can now be mined. So the newer models are packed with sophisticated sensors that facilitate the extraction of different types of vital signs even without the need for external devices. These sensors, when properly used, can provide valuable health information for the management of many long-term illness. For example, the video cameras of mobile phones can be used to collect heart rate and heart rate variability, embedded accelerometers, and gyroscopes to track energy expenditure. Moreover, the pulse transmission time, as measured by time delays between electrocardiographic and photoplethysmographic sensors, can be used as a surrogate measures for blood pressure. So this information can be calculated from two devices that connected with a mobile phone independently. One with an electrocardiographic sensor and the other one with a photoplethysmographic sensor. So when when connected to health providers, a closer level of interaction in healthcare can be maintained toward greater personalization and responsiveness. Social health. Uh, One of the primary tasks of telemedicine involves connecting patients and doctors beyond the clinic. However, this communication has been expanded with the involvement of social networks to new levels of social interaction. This new feature has opened up new possibilities of patient-to-patient communication regarding health beyond the traditional doctor-to-patient paradigm. One-fourth of patients with chronic diseases, such as diabetes, cancer, and heart conditions, are now using social networks to share experiences with other patients with similar conditions, thereby providing another potential source of big data. So, in addition to biological information, geolocation and social app provide an additional feature to understand the behaviors and social demographics of patients while avoiding resource intensive and expensive studies of large statistical sampling. So this advantage has already been exploited by several epidemiological studies in areas such as influenza outbreaks, collective dynamics of smoking, and the misuse of antibiotics. So text messages and posts on online social networks are also a valuable source of health information. For example, for better management of mental health, compared to traditional methods such as surveys, fluctuations, and regulations of emotion, thoughts, and behaviors analyzed over social network platforms such as Twitter, offer new opportunities for the real-time analysis of expressed mood and its context. Uh, for example, when validating against known patterns of variation in mood, emotional tweets collected over a 12-week period in a study reported by Larson et al. Claimed to find some correlation between emotion tweets and global health estimates from the World Health Organization on anxiety and suicide rates. So health data challenge. So what's the challenge that face big data and storing the data and let's say sorting these data. In fact, according to the American Health Information Management Association website, the modern healthcare industry struggled to manage data. In the quest for data, electronic health records have been created to import large amounts of data, storing every keystroke and data point. In fact, in today's era of big data, uh, frivolous, meaningless, and unstructured data is collected and stored next to meaningful data. While computers and hard drivers are exceptional at sorting through mounds of structured data, humans are not. So computers cannot distinguish good data from bad data, and unstructured data is more difficult to parse. Human interaction is required to interpret the data. It's essential to balance usability with functionality. In addition, healthcare professionals lack background and understanding of data science. This fact further complicates the copious amounts of data entered without the appreciation for the potential that data could yield. Therefore, a multidisciplinary field such as health informatics is needed to deal with the big data issues that are arising in healthcare. Uh, they should be able to sort through volumes of data for health intelligence purposes. So, by digitizing, combining, and effectively using big data, healthcare organizations ranging from single physician offices and multi-provider groups to large hospital networks and accountable care organizations stand to realize significant benefits. Uh, Potential benefits include detecting diseases at earlier stages when they can be treated more easily and effectively, managing specific individual and population health, and detecting healthcare fraud more quickly and efficiently. So, big data analysis. Uh, so, bi- uh, what's the big data analysis? What's the role of big data analysis? The significance of analyzing big data. So, big data analysis is the packaging of that data into a comprehensible formats for human analysis processing to detect trends and patterns that may offer actionable insights. So, how does big data analytics fit into healthcare? By collecting, maintaining, and analyzing more information about an individual's health, doctors can diagnose more holistically and even proactively. Okay, how big data analytics can improve patient outcomes? So the two big uses cases for the big data analytics in healthcare are predictive risk modeling and proactive intervention. Uh, so Using general population data comprised of lab results, questionnaires, biometrics, and more patterns that may lead to particular conditions can be identified. By collecting data on the individual, the correspondence to those patterns can be used to assess the risk of developing that condition. This kind of risk modeling is crucial in an area typified by lifestyle diseases like cancer and diabetes that are best and most cheaply treated by preventing them in the first place. Similarly, continual monitoring of an individual's health can lead to proactive interventions as their vitals and exercise patterns begin to match the pattern for prediabetes. For example, they can be called in to see their family doctor for personalized recommendations on how to avert the transition into full diabetes. As mentioned before, numerous questions can be addressed with big data analytics. According to McKenzie, he estimated that big data analytics can enable more than $300 billion in saving per year in United States healthcare. Two-thirds of that through reductions of approximately 8% in national healthcare expenditures. According to that, we can recognize the significant and importance of big data and minimize in healthcare delivery cost and meantime improving in healthcare delivery and patient safety. So this is in this slide and next two slides, I think, the list of references that I have used for this lecture. So well, this is the end of our lecture for today. Thank you for your listening. I hope you find the lecture nice, simple, and interesting. Um, the next lecture will be uh, we are going to introduce electronic health records and their use, and we are going also to describe the fundamental components or processes of health information systems and implement confidentiality and security procedures to protect electronic health records. Uh, uh, Thank you again, and bye for now.